You know what? It's the end of the semester. I guess we're getting people really failing out and trailing off. Does anybody in the classroom that you know, love, or would hate to see them fail? Reach out to them, let them know the class is going on. I actually don't want to spend time texting the entire class today. Um, but if there's people that you worry about or you care about, please reach out to them. What we're going to do today is we're going to continue on for 11.1, right? We got to a certain point, and I'm going to want to start now just because there's two things I really want to do. And I want to make sure that you guys are really able to play with both, as opposed to me teaching you and showing you something and then saying, go off and do it. I want to make sure that you guys are able to kind of do part of it in class to kind of help you out. Now, one of the things I asked everybody to do is to have that little handout handy that I emailed the entire class. I hope that's what's maybe that's what's keeping people. You know what I mean? They wait till the last minute, like, oh, snap, let me print it. And I hope that those of you who are here actually have that handout. But let me get started just so we can actually get to it. That'd be real angry. Dr. Barnes made me print this. I was late and we didn't even get to it in class. It's legit. All right. Now, talking about the chi-square. This right here is a slightly different example. In class, I think we did the example about comparing apples, mangoes, watermelon, strawberries, and grapes, right? But what I actually found is another slide. I actually feel bad for y'all. I actually use the data and example up. But the best, more recent presentation that when I used, when I was talking about the goodness of fit table, I used a vignette. And actually, I remember I was teaching in front of my classroom and I looked out my window and I saw yet another Honda Odyssey that just went through my neighborhood and damn near flew off the speed bump, right? I sat back and laughed like it's a damn shame these soccer moms, I guess they're so late to go somewhere and they just feel like they can fly over speed bumps, but those cars aren't built to do that. But so I sat back and had a story about, all right, Wilmington, Delaware, which is where I live, what type of vehicles exist. And we talked about the homeowners, we look at our certain homes, and I made up some data talking about looking at 92 homes and what do people own? Do they own sedans, minivans, SUVs, sports cars, motorcycles, or pickup trucks, right? So those are the types of categories for that one variable. Now, me, I was being obnoxious because I sat back and was just like, I'm thinking sedans and minivans are the number one. And actually, no, minivans is number one because I see them all the time. Little bad ASS kids be jumping out. Figured there'd be more. This is kind of based off my theory. That's my prediction. These values will add up to one, like we said before, right? And then as a result of that, we walked around, saw 92 cars. Me and my kids, we walked around the neighborhood. We had a little walking the dog. We counted up the 92 cars, and it's the math. This is what we actually found in my neighborhood, right? So these are my predictions based off my hypothesis and or prejudice, AKA the same thing, right? And this is what we actually observed. Now, the reason why I'm going to this example right here, and I'm switching it up a little bit, is how do we figure out what the expected values are, right? So we're not comparing apples or oranges anymore. We're comparing different types of vehicles in North Wilmington in my neighborhood, pretty much, right? How do we sit back and find out what the expected values are? Well, there's two ways. One way, we got to sit back and think about our hypothesis, or I was saying before, our prejudice, right? When conducting a goodness of fit test, requires that we identify the observed frequencies, right? That's, oh, we go out there, we actually observe, we record the data, we're not going to lie, we're going to say what it is, right? And then we have to find the frequencies expected based on our claim or our hypothesis. Now, there's two different approaches. It depends on what we're saying. Now, my example here, I'm saying that I think that minivans are definitely a favorite. I thought sedans were next in line, and these poor husbands who can't get their sport car, right, until their kids grow up, that's very rare. The poor husbands who want a motorcycle, right, that's actually rare, right? And again, I hate to be sexist because I guess there are some females who want sports cars, and there's also some females who want some motorcycles. So I take that comment about poor husbands back. Maybe we got some biker chicks and some sport car chicks, right? But again, those ratings of those vehicles in my neighborhood were lower. That's my hypothesis or my claim, my belief, AKA my prejudice, right? Now, to do this, I got to put my money where my mouth is. I got to give myself kind of a quantity. So I was saying, oh, I think about a fourth of the cars are sedans, more than a fourth are minivans, right? So when I put my money where my mouth is in this way, right, and I speak within the realm of a probability, which means that all of these added together must equal 1, then I can do the expected frequency, right? The first way is when they're all equal. We're not going to do that. I'm going to jump into if the expected frequencies are not equal, because that's what I did, right? If they're not equal, what we do to find out the values of E, we use N times P. Now, again, this is a critical thinking. This is building upon each other. What does N equal, guys? And I'm not asking for a number because it's not on this page, but I am asking for, when we do statistics, what does N typically stand for?
The number of trials or like the total observed like sample values.
Yep. Number of trials, right? Or observation. I'm going to say OBS. Excellent. Now, what does P stand for? Now, this might be a trick question, so I'm actually going to go to the previous slide and sit back and let you guys see it, because P can mean several different things. It could be like the probability and stuff like that as well. In here, what does P equal? Now it's up on the screen. It's almost telling the key person that can read, but what does P stand for?
Probabilities.
Probability, right? And I'm going to say prob, right? And I'm going to say of each category. Notice that each category, I'm going to say each category. So the probability of motorcycles is what?
0.25.
Uh-oh, I heard 0.25.
Oh, sorry, no, 0.05.
Okay. Probability of sedans. I'm going to call on you again, Jasmine. You're going to redeem yourself. You'll get it right the first time.
0.25.
There we go. See, we're always right deep down inside, right? Now, according to this process right here, we would sit back there and find out, since these are not all equal, right? I got a biased belief. In order to find out the expected frequencies, we're going to take N and multiply it by P, right? That gives us, N is 92. Me and my kids, we walked my dog and we found 92 cars in one dog walk, right? Those values are right here. Now you can double check, and I actually challenge everybody in this chat. That's what I want you to do. Everybody in this room right now, we got 6 additional people. I want you to pick one of these values. I want you to say, Dr. Barnes, I don't think you're right, right? And I'm gonna show that I'm at least trying to prove me wrong, because you're gonna pick one of these, whether it's sedans, minivans, SUVs or not, but you're gonna put the math in there. Now, what I mean by putting the math in there is saying that, okay, we got to do N times P. So if we're going to do motorcycles, right? N equals 92, and N, and P is not on this slide. I got to go back to the last one. I'm sorry, guys. Right? We're going to go back to this slide. And so N would be 92, and P would be 0.05. So I want you to put in chat, and I'm going to do an example for this right here. We're going to put in chat the fact that we got 92. Why is it not showing up? 92 times 0.05 equals 92 times 0.05 equals 4.6. I'm going to put in parentheses and make sure you do it like this. I need one of those. You can pick any of the categories. Just don't pick motorcycles. I already did that.
In a private chat or just a chat to everyone?
You can do it in a chat to everyone. All right, I should have 6 comments. Why am I getting texts from people wanting me to sell my house? The hell? One, two, three, four. I'm waiting for 2 more. Oh, wait, hold on. 1, 2, 3, 4, 5, 6. Okay, I got them all. This chat's kind of funny, man. It definitely is kind of funny. All right, excellent. Now, I guess I could double check them, but I'll go down to this next slide where the answers are, right? And I'll look at the chat and see if anybody gave me a wrong one. All right.
Why is SUV 15.33 and I got 18.4?
All right, 18.4. Ooh, hold on. Hold on, let me make sure. Maybe I messed up. Oh, yeah. Guys, don't listen to me. These numbers right here are not right. Yeah, these numbers are not right. Okay, for us, the values that you guys put are accurate, right? I'm using just the danger of using PowerPoint, right? Because with using PowerPoint, I can't really change them. The number that you guys gave me, I'm sure are right. Unless anybody is questioning them, I'm sure they're going to be right, right? Now, here's the issue. When I go back to this slide, I mentioned that there's 2 approaches that we can use, right? So on this slide, I was trying to figure out, I had a prediction that they're different. I brought my bias in, I brought my claims in. My hypothesis is not that the expected frequencies are equal. My hypothesis and my claim is that they are unequal. So I use this approach. They are not all equal. And as a result of that, we had to do N times P for each individual category, right? You guys did that. I saw the math. I trust you, right? That's right. Now, the next slide that I was showing you, right, which had you kind of probably thinking you did something wrong, but y'all smarter than that. This is saying that the expected frequencies are all equal, right? Now, that goes against the situation, but that's being like, what? There's 6 different types of cars, SUVs, motorcycles, I don't know, SUVs, motorcycles, sports cars, sedans, right? And we don't think that there's any preference between those. They're equally likely. If we would have walked through my neighborhood, we would have saw an equal number of motorcycles, SUVs, sedans, sports cars, etc. Now to do that, it's a different equation. To find out our expected values, it's just N divided by K, right? K is, what does K stand for? Does anybody think they remember from last time? Across the mountain, put a K.
The number of different categories.
Ooh, go ahead, Siani. Number of categories, right? Now, our number is N. And our number is N. N is 92. I'm going to do the math right here. I think there were, how many categories were there?
I think it's 6 because on that other slide you have the pickup category.
Yep, absolutely right. Now, if you want to, I'm doing it right now. 92 divided by 6 equals 15.33. That is what I was showing you guys a second ago, and why y'all were just like, whoa, my numbers is wrong. My numbers is wrong. And let's go down to it. Right down here, this is assuming that the categories are equal. 15.333, repeating. That's assuming that I don't think there's any difference between sedans, minivans, SUVs, sports, et cetera, right? So you really got to think about what your claim is in order for you to find out the expected values. You got to figure out what the claim is. All right, so I apologize for that little distraction. Let me see. There's no reason to go here. Yeah, this is the same thing. There's no reason to sit back and do this. I think we've done this. Unless anybody is lost or confused on what we're saying about that. I'm not going to go over that example of how to either use n divided by k if you think they're all equal, right? Or to use n times p if you do not think that they are all equal. All right, I need to fix that in the future. All right, you guys can send me a little message in the chat if you're lost, if you don't get the difference between how to use these two approaches. I definitely can go back over it if we're lost. All I need is a little private message in the chat, like, I don't understand. Okay, all right, let me see this. Okay, so I'm going to use this right here. I'm going to use this slide. This right here is a perfect example of what we would do in two different situations. All right, so this is different data that we have, but we're going to do this data two different ways. Up top, we're going to predict, and our hypothesis and our claim is going to say that we think that the expected frequencies across these 1, 2, 3, 4, 5, 6 categories, right, are all equal. Now, according to this right here, this says that if we think all the categories are equal, which is what we're saying right here, we use this equation. Our expected value, E, this E right here, stands for the E that's right here. We're going to take N and we're going to divide it by K. Now, I just said, what does K equal? K is a number of categories. K is 6. So K equals 6. Now, in this example, what is N? Uh-oh, it's a real question, people. What is N? All the information you need, I promise you, is up here.
5.
Yes, 45. Everything you need is in this little box right here. All right, so let me change the color. N is 45. So the equation we're going to use is, I'm going to put it over here. E equals N divided by K. E equals 45 divided by 6. Take our baby step again. E equals what? Who can do that for me? Actually, I'm going to ask for some more participation. I'm doing it right now in real time, but I want each of you to do it as well and put it in chat and send it to me privately. Don't ruin it for everybody else. We got 6 people. I need 6 answers sent to me privately in chat. All right, got 1 correct, excellent. 2 correct, excellent. 3 correct, 1, 2, 3, 3 correct, excellent. Uh-oh, now we need to, I got somebody I need to talk to, right? And you know what? I probably see where they are. I see this answer. All right. Oh, I got 2 people that got some stuff wrong. Let me see. Okay, now I'm a little confused. One of the things I see in the chat, right? And we've got to make sure we're with me right now. The equation that we're going to use is this right here. E equals N times K. Now, earlier we sat back and said N equals 45, K equals 6. And we did this math right here, 45 divided by 6. Right? Now, I'm worried because in the chat I saw this, and I don't even know how to get to that wrong answer with what we did before, is somebody suggested that solution would be 45 times 9, right? But that's not consistent. One, the operation isn't even the same. We're supposed to divide, right? And then the value of 6. So again, I keep telling you guys, this is really about building, right? It's building. We went through this process of what's K, what's N. Here's the equation we're going to use. Let's plug in the numbers, and a 5 times 9 kind of comes out of nowhere, right? Another answer I got that was different, and I actually see this when it kind of makes sense to me, right? Now I see where one of the answers I got that was wrong was this right here. Somebody indicated and provided a value of 3.15, right? And let me tell you how they did that, right? In order to do that, they didn't use K, they didn't use N, which is what we're supposed to do when all things are equal, right? I think what they did is they used the wrong equation about we're going to calculate it by taking N times P, right? Now they use N equals 45, and then they multiplied 45 by a value of 0.07. I'll be honest, I don't know why they did that or where that number came from, but that got them to a value of 3.15, right? Now, if I were to say that they are not equal, that would have been appropriate. But what we're doing up here is we're factoring in this whole chart up top when things are all equal, right? And when they're all equal, we're going to use this equation. And this equation, 45 divided by 6, gives us a value of, like many of the comments that we had, a 7.5. So all of these, this should be 7.5. I think it's going to be equal. This should be 7.5. I think it should be equal. I don't think there's going to be any difference between here. This category will be 7.5. Let me move this out my way. This category will be 7.5, and this category will be 7.5. Now, what I want y'all to do is do me something, a little favor. I want y'all to do the math of this. 7.5 plus 7.5 plus 7.5 plus 7.5 plus 7.5 equals, and y'all let me know what that equals. And put that in chat as well. All right, I heard somebody say something. Is that a question?
No.
Okay.
Well, yeah, actually, yeah. So the values we're dealing with right now are the same ones on the worksheet. So should we?
The same values that are on the worksheet? No. Don't jump on the worksheet. Stick with me. And honestly, that's the easiest way for people to get lost. Maybe that's what's going on. Don't worry about the worksheet just yet.
Okay.
All right. Everybody's able to do that math, right? 1, 2, 3, 4, 5. I got 1, 2, 3, 4, 5. I need one more, but I imagine that's coming in a second. Yeah, I got all 6. Now, the number that everybody put in the chat, and they got it right, is our 45. And if you say that number matches the N, and that's exactly what we're doing. We're saying, look, we think all categories are equally likely. So at the end of the day, there should be 7.5 in this category, 7. And that means they're all equal. They're all equal. Now, that's not the case on this next one that we're going to use at the bottom. Now, I mentioned before, the one that we're about to do right now on the bottom, this is when we assume that the expected frequencies are not all equal. And since we think that they are not equal, we're going to use a different equation. We're going to use E equals N times P. Right? Now, stick with me. This is important. I think I got to remind us to stick with me when we're doing stuff, right? NE equals expected. That is the same E. This E is referring to this E, right? And then I guess that E as well, right? N equals what? And then P equals what? And I'm going to focus on one of these categories, right? We got 6 people in the class, so I'm going to do the last one, right? This is the one we're looking at right here. I got this little arrow right here. What is the value of N to figure out this expected frequency?
45.
45. And again, just to let you guys know, N will always be the same, right? Somebody else, please. What will be the value of P if we're trying to fill out this category?
0.03.
0.03. Now our equation is E equals N times P. We're going to translate that into N equals 45 times 0.03. And that value, kind of what we did right here, is going to be 1.35. But we got to do it for each category. So when we do it for the first category, which has a probability of 0.28 because of our claim, 45 times 0.28 equals 12.6. When we do it for the second category, 45 times 0.40 equals 18. Now I'm going to show you something again. Do the math. Promise you, I want you guys to see this. When we add this, plus this, plus this, the value that we're going to get as a result is what?
You want it in the chat?
No. You can just say it out loud if you guys got it. I'm actually going to put it, and I want those of you, you can put it in chat if you added these numbers up and you didn't get it. Send it to me privately, and that will just let me know that we got somebody out there that needs a little help. Maybe I could try to find out what it is. All right, I don't see anything in chat. I think you guys are good. All right, now we went over this hypothesis already, so I'm not going to do that. This right here, I kind of messed this up for y'all, but this is just another example, right? Now I want to show you guys how this equation works. No, guys, give me 1 second. Let me pause recording real quick. I'm going to, okay, now I'm back. And I just wanted to make this a little bit easier for us to sit back and actually do, as opposed to halting down. Now, this equation that we're going to do is very, very challenging. And it's one of the things that we have to really sit back and make sure that we understand. So I'm going to focus a little bit on this. I'm going to slow down to make sure we do it. Right now, the one thing that we can do is we need to make sure that we understand what this means, right? This is like kind of the summation. So it's not like multiplying it by a value, it's like a summation. Essentially what it's saying is we're going to take the summation of each of the observed minus the expected, right? We're going to square it, and then we're going to divide it by E, right? Now, what I'm going to do is this. I'm going to ask for a participant to, we're only going to focus on the first one right now. But I need a volunteer to tell me what they think the math should be if we're going to take the observed minus the expected, square it, and divide it by E. Now, I'm not telling you to solve the equation. I just want you to plug the appropriate numbers in. All right, and I'm going to ask for a volunteer, and I hate to do this because I know it's so much easier to go follow up, but I am going to call on somebody to go first. I'm hoping it's somebody that has a little bit of thick skin and is okay making a mistake and just keeping it moving. I'm going to say, ooh, Jasmine Mays Lofton. Can you sit back and try to attempt to do this equation for what circle? So we're looking for O, and it's going to be in this red circle to help you out. We're looking for the value of E. It's going to be in that circle, I promise you. Yeah, what do you think those values will be?
So E would be 13.
All right, now here's the issue though. We're not doing E first. So what's the first one that comes first?
Oh, I meant to say O. O would be 13.
All right, 13.
Minus E, and then I got to do the math for that. 45 times 28. Times 28. That'd be 1260.
All right, but you know what? I already have it up here. So I went back and took that time. It's already on the screen. I'm trying to make this a little bit easier than you wanted it to be.
And then we would square that first half.
Okay.
The numerator. Then E would be the denominator would be 12.6.
12.6. All right, you did it, right? So now I'm going to call in the next individual. See, I thought this was going to be hard. I was like apologizing, like, I'm sorry, Jasmine, I'm going to put you under the bus, but she's able to do it. All the information that she needs is right in here. Our next volunteer, I'm going to go from Jasmine to Jasmine.
Would it be 6
Yeah.
minus
Playing Jeopardy, y'all. You hear that? She's playing Jeopardy, but that's all good. 6
minus 18?
minus 18. Yeah.
That squared all over 18.
There we go. I told you I was feeling bad that I'm putting y'all under the bus, right? But y'all know what y'all doing. All right. Now I'm going to go with you never can go wrong with wisdom, right? Her name implies she's going to get it right.
Okay. So you're gonna do 12 minus 3.15.
3.15.
Close parentheses squared over 3.15.
Excellent. All right. Then I'm going to pick, who else am I going to pick? Who else is in here? Siani. Everything you need is right in here.
You're going to do 9 minus 2.25 squared over 2.25.
All right. I'm trying to stump y'all. I ain't getting nobody yet. I'm upset. Like, what's the whole point of being a teacher if you can't make somebody cry because they get it wrong? Dang. All right. Okay. Let's go next. That would be Naris. Everything you need will be in here.
Okay. It would be 3 minus 7.65 over 7.65.
And you know what? I helped you a little bit, but the one thing you did forget.
Oh, the 2.
Square. Yep. All right. And then last but not least, I got to look on the participants. I think that would be you, Deja. I feel like Deja just spoke though. All right, let me do this color. I guess it's an ugly color. All right, everything we need is right here.
Oh, 2 minus 1.35
1.35
squared
squared. Perfect.
over 1.35.
1.35. Right? And then we're going to do equal. Now, this is what I'm going to do right now. I think this is really perfect when it comes down to homework. It's going to be perfect when we sit back and do this for some of the math exams and some of the items you want. Now, I use this, but it's not a terminology in the textbook. I might sometimes say we have names for these, right? This is A, this is B, C, D, E, and then F. Now, everybody did one of these. What I want you guys to do is I don't want you to go through, because this is the summation. That's what the summation means. The summation means that we're going to take this, which is consistent with that equation, add it to this, add it to each of these. We're going to take the sum of all of them, right? But what I do for the homework to make it so, because if you make a mistake at one of these spots, it can mess everything up. I just want you guys to do the contribution of the one that you did. Forget who did what, right? But everybody did their own unique item. I just want you to do the sum or calculate the value of the one that you did. Now, I do remember that Deja was last. I think I went with the 2 Jasmines being first. I ain't gonna lie. Wisdom, yeah, then Siani and Naris. So you guys know which one to do. I just want you to do that one that you did, not do the entire sum, but just the one that you contributed. And that's talking about like your unique contribution to chi-square, not solving all 4 chi-square, but the unique contribution of like one of these categories. I'm gonna stop talking and ask you guys to do that.
Send it in the chat.
Yeah, if you want to put it in the chat, that'll work. And you can do it publicly. It doesn't have to be private because everybody's going to be different. All right, so if I remember how this works. All right, Siani gave me hers. I think I know where she is. $20.25. Now Reese gave me hers, 2.83. Jasmine gave me hers. Wisdom gave me hers. Oh man, we lost somebody. And Deja gave me hers. All right, let's do it for the one that's lost, for the one who left. I'm sure their internet's messed up.
I got 8 for Jasmine.
So did I. All right, now, in order to get the value of chi-square, right, what we would do is we would add all those values up, and I'm going to do that. 0.0127 plus 8 plus 24.86 Whew. We got a chi-square value of 56.60. I'll say 3. Now, I'm gonna be honest with you. I know for a fact. Now, what we would really do is we would go to the back of the book. There's a chi-square distribution chart like we've done for everything else, right? We would look at the number of categories. We would look at the value of our significance level, and we would pick the appropriate critical value. And if what we obtain right here is greater than that critical value, then we would argue that it is significant, and we would reject the null hypothesis. Yep, we'd say it's not true. But a value of 56, let me tell you, I know for a fact, so I'm not going to go through and look at the table A4 in the back of the book. I just know for a fact it's going to be greater than that value. And it's the same logic that we've done with everything else. All right, clear all drawings. Now, we are actually yeah, I'm just going to have you guys do this individually. Ooh, is my computer about to die? Yes, it is.
So this, Dr. Barnes. Oh, I'm sorry.
No, go ahead. What'd you say?
This, when I did it on, well, I actually didn't do it on the handout sheet, just because I was a little confused. Like I was like, so far they gave us like everything, and I don't know. I guess I didn't know. Well, I didn't try, so maybe that's the problem.
All right, now let me know. We got 3 minutes. I want to elaborate on what's confusing you about this, right? Now, I'll tell you, one of the things that's really key to attend to when you do this handout, right, is making sure you attend to right here, this note. Expected frequencies are equal, or they'll say expected frequencies are not equal. Now, it's very subtle. It's underneath all of them. It will just let you know about how each of these aspects, whether you should use what equation. If you're using n divided by k, that's what you would do when you're using all are equal. Or if you're saying they're not equal, that's when you would do n times p for each individual category. For each individual category. Now, for this assignment, you probably just want to print these things out, do the answers. Now, this is what the reason why you definitely want to complete this assignment. Complete the assignment, and then you're going to take another handout quiz. And that handout quiz just opened up right now in class, right? Now it's going to be open from now up until Monday. But when you do this handout and you get the answers correctly, when you take out the handout quiz, it's called handout quiz 2. That's what I call this one. Not just the first handout quiz. It's kind of like handout 2, handout quiz 2. You will be putting the answers for this into that quiz, and it will let you know. I kind of wanted to do it in class, but we took a couple seconds to review something a second time, and I don't want to rush, but I do think that we spent enough time focusing on that. You guys should know the skill. I will stick around for 3 or 4 minutes. If anybody is confused on any one of these handouts and would like some verification that they're doing it right on one of these items, I can do that. But if not, I will tell you guys, thanks for coming to class. I am 1 minute shy of class ending. It's Friday. I'll let y'all have that minute. You guys can go enjoy your weekend. Don't forget to do what you got to do. That's handout quiz 1, handout quiz 2, which is this, the math exam, If you want to keep up with the course calendar, they're due Monday. That's when you want to do it. If you wait to the end date, we will have been talking about 11.2 for a week, and you'll be very, very confused. And then also on Monday, you guys will be taught by our guest students on how to do the homework for 11.1. So I'll see you guys Monday. I'll be here in spirit, not necessarily present. All right, guys, thank you for coming to class.